Hey everyone, welcome back to my YouTube channel. Our solar system is a place we think we know intimately. From the fiery embrace of the sun to the icy depths where Neptune reigns, we have mapped its planets, charted its asteroids, and cataloged its comets. For centuries, this cosmic neighborhood has been our scientific playground, a place of profound discovery that has reshaped our understanding of our own existence. We send probes to Mars, orbit Saturn, and even touch the very edge of interstellar space. Yet, despite all our technological prowess and accumulated knowledge, there remains a tantalizing whisper, a ghostly presence that might be lurking in the absolute furthest reaches of our celestial home. It is a whisper of an unseen world, a colossal planet whose gravity subtly tugs at the fabric of our solar system, an elusive giant known only as Planet 9. Imagine for a moment the cosmic ballet of our outer solar system. Beyond Neptune, the familiar dance of the major planets gives way to a vast, dark expanse known as the Kuiper Belt. This region is a cosmic junkyard, filled with icy bodies, dwarf planets like Pluto, and countless smaller remnants from the solar system's formation. For a long time, we believed that these distant objects moved in predictable, if somewhat chaotic, orbits, governed primarily by the gravitational influence of the Sun and the occasional nudge from Neptune. But then, astronomers began to notice something peculiar, something that defied the expected order. It was a subtle anomaly, a pattern in the orbits of a specific group of distant, icy worlds that seemed to hint at an invisible hand, a gravitational puppeteer pulling strings from the shadows. This was the first, faint tremor that would eventually lead to the audacious hypothesis of Planet 9. These aren't just any icy rocks we are talking about. These are what scientists call extreme trans-Neptunian objects, or ETNOs. They are small worlds with orbits so elongated and so distant that they spend most of their time far, far away from the sun, venturing into regions where its light is barely a glimmer. As more of these ETNOs were discovered, a strange coincidence began to emerge. Their orbits, particularly their perihelia, the points where they come closest to the sun, seemed to cluster together. Not only that, but their orbital planes also appeared to be tilted in a similar direction, almost as if they were being shepherded or aligned by some unseen force. It was like finding a dozen boats in a vast ocean, all drifting in precisely the same direction, even though there was no visible current or wind. Such a phenomenon, in the cold, hard logic of astrophysics, rarely happens by pure chance. The odds of this alignment occurring randomly were astronomically small, leading scientists to consider a more profound explanation. What if, instead of random chance, there was an orchestrator, a massive, hidden body whose gravitational influence was shaping these distant orbits? This was the core astronomical mystery, a puzzle piece missing from our grand cosmic picture, and the beginning of the hunt for the solar system's elusive ghost. The idea of an unseen planet influencing the orbits of known celestial bodies is not new. In fact, it has a rich and successful history in astronomy. Our journey to understanding the outer solar system has often been guided by the gravitational whispers of unseen worlds. Consider the discovery of Uranus in 1781 by William Herschel. Its orbit, while generally predictable, exhibited subtle deviations that puzzled astronomers. It seemed to wander slightly from its expected path. Decades later, mathematicians like Urbain Le Verrier and John Couch Adams independently hypothesized the existence of another, more distant planet whose gravitational pull could explain these discrepancies. This led to the spectacular discovery of Neptune in 1846, precisely where Le Verrier had predicted it would be. This triumph of celestial mechanics set a powerful precedent. If a planet's orbit is perturbed, look for another planet. This historical success story laid the groundwork for the modern hunt for Planet 9. Fast forward to the early 21st century, and the astronomical community was buzzing with new discoveries in the Kuiper Belt. We were finding more and more of these icy bodies, pushing the boundaries of our solar system knowledge. It was in this context that two astronomers at Caltech, Konstantin Batygin and Mike Brown, began to meticulously study the orbits of these distant objects. Mike Brown, already famous for his role in the demotion of Pluto to a dwarf planet, had a keen eye for the peculiar. In 2016, they published a groundbreaking paper that brought the Planet 9 hypothesis into the mainstream. Their initial work focused on 6 specific ETNOs, all with highly eccentric orbits that swung far out into the darkness. What Batygin and Brown noticed was that the perihelia, the points where these objects came closest to the sun, were all clustered in roughly the same direction. Furthermore, the planes of their orbits were also tilted in a similar way, approximately 30 degrees downwards relative to the main plane of the solar system. To them, this wasn't just a coincidence, it was a strong statistical signal. They calculated that the probability of this clustering happening by chance was incredibly low, something like 0.007%. Such a low probability strongly suggested that something was actively herding these objects into their unusual configurations. Batygin and Brown proposed that this something was a massive, as yet undiscovered planet. They estimated that this hypothetical Planet 9 would be roughly 5 to 10 times the mass of Earth, placing it somewhere between Earth and Neptune in terms of size. Its orbit, they theorized, would be extremely wide and eccentric, taking it perhaps 200 to 1200 astronomical units from the Sun. To put that into perspective, Neptune orbits at about 30 astronomical units. This meant Planet 9 would be hundreds of times farther out than Neptune, completing a single orbit around the Sun in a staggering 10,000 to 20,000 Earth years. Such a distant and slow-moving object would be incredibly difficult to detect, even with powerful